So today I'll discuss the equation longest path in a matrix. This is one of the very important question, you can say. What is this question? Let us go to the problem. So there is one 2D matrix, okay, of size let's say n cross m. What you need to do, you need to start from the first element of the matrix, which is starting node of the matrix. So start from 0 0, that is the first node of the matrix. Now you can go to the right side or you can go to the down side. From each point, from any node in the matrix, you can go towards two directions, right or down, such a way that the next element value should be greater than the current element. For example, if you are at the index a of ij, you want to go to the a of I plus 1j, you can go there only if a of I plus 1j is greater than a of ij. Similarly, for the when you are moving to the downside, then also that node value should be greater than the a of ij. So this is the condition. What we need to find? We need to find the longest path. Longest path with these conditions in the matrix we need to figure out. For example, let us take one example. Here the starting node will be 1. So here you can see that starting node will be 0 0. That is the starting node. Sorry guys. Now from here you can go to the right side or down side. So here both are greater. I need to take both ways. So if I'll go to the 0 1, here value is 2. Okay, so here value is 2. Now from here you can take again right or down. Now this is the last column, so you can just go to the down side. So the next will be 1 1 comma 1, whose value is 4. Okay, whose value is 4. So you reach to the end of the matrix. So the length here is nothing but 3 nodes we have covered. 3 nodes we have covered. Now still from 0 comma 0 there was one more possibility, which was I can go 1 comma 0 instead of their value was 3. From here also I can go 1 comma 1, which is 4. So here also length is the 3 nodes we have covered. Okay, so that is the thing. So your answer will be max of these two, max of path 1 and path 2. In this case that will be 3, which is 3. Okay, understood? So we will try to do the code for this question. Okay, so let us go to the Eclipse. We will try to do the coding. Now let me create one new project. These questions are very important actually for the interview purpose. If you are going for any coding interviews, these questions plays very important role. So longest path. Okay, now I'll create one class. So longest path in a matrix, let's say. Okay, here I'll just define the matrix as the hard coding. in the actual question you can take these as input also. So number of row in the matrix, number of column, these are the two variables. Now let's say we are taking the same matrix, so row will be 2, column will also be 2. I'll define the matrix. Let's say the matrix, which is nothing but the new int. All right, here I can define the matrix 1 2, that is the first. All right, 1 second. So whenever we are directly initializing, no need to write this thing. You can simply do this way. Now here you can say 3 4. So matrix we have defined. This is the 2D matrix which has size. So what problem we are having? Syntax error. All right. Oh, there is one curly braces missing. Yeah, that should work now. So what we want, first of all, let's say we will call a method for which will give us the maximum, which will give the path whose length is longest. So I'll call a function, let's say find longest path. What all I need to pass? I need to pass the matrix, I need to pass the number of row, number of columns, and the starting node, which is 0, 0 in this question, right? Let us define this function. All right, so we will return one integer and find longest path. All right, so this is the matrix int row, int column. I can say int I and int g, which is the starting node. Now very important thing, base case. I'll talk about this thing. So what is the base case here? So this ij is the node where you are at. From this node you will go to the either right side or down side. Okay, so first condition I and j should be, if they are less than 0, means we cannot go that way, otherwise it will throw integer out of bound exception. Similarly, j less than 0, which is not possible. And same way we need to apply the condition for the last row or the last column. So this is the most important base condition. If this is the case, just return 0 from here. Okay, we'll see why we are returning 0, why we are returning 0. We'll understand this thing, no problem. Now what you need to do, you are at ing. From here you can go in right direction. You can go in right direction, or second thing, you can go in left direction. These are the two possibilities we have at the index ing. So what you will do, when you can go to the right direction, tell me. I can go to the right direction if matrix of I j plus 1 is greater than the matrix of ij. That is the question requirement, right? If this is the case, that means I can go to the right side. Oh, so it should be the matrix. All right, that means I can go to the right side. So here I'll just let's say I'll call the same method. Okay, I just call the same method with the matrix. Row column will always be same, and I will be same, j will be j plus 1. All right, this will return us some value. Let us store this value to some variable, and we can give, let's say, int result is, let's say we are saying integer dot mean value. All right, so what you will do here, result equals to, here we can apply the max because we want to find the max here. So do we have this function or not? I think we are. Dot max we have. All right, perfect. So first will be result and second will be longest path. So I'm just taking one variable result, which is why we are initializing with the minimum value, because here we want to find the maximum. One simple trick I'll tell you: whenever you are looking for the maximum value, take the variable, assign it the minimum value. When you want to find the minimum length, take the variable, assign the maximum value. All right, now when we can go to the right side, let me take the same. Okay, we just need to change ing. So here, instead of this one, I plus 1 I'll do, and here I just need to do the I plus 1, and that is the j. All right, now so here what it means, that from this ing I can go in these two directions. Once I went to this direction, I'll get the value of maximum path length in this result variable. So from here I'll just return the result. All right, from here I'll just return the result. This is the code. Okay, now let me check once. Yeah, so whenever you are doing this kind of thing, okay, you are not sure about the j plus 1, you are not sure about the j plus 1, so here you need to apply the condition that j plus 1 should be less than the column, and only otherwise it will throw the integer or throw exception, index out of bound exception. Similarly here also you need to apply for I plus 1 should be less than the row. This is a very important conditions. All right, so okay, let us try to run it. I'm not sure what will happen. Something went wrong. So this is the minimum value, here we are taking the maximum value. Oh, sorry guys, so here I'm not increasing the 1, because you need to increase the 1, right? So 1 plus, because we are going to the next node, that means length we need to increase, and once you reach to these nodes, means they are not the value, just return the 0. All right, let us try one more time. Something is wrong. One second. So what we are doing, let's try to go through the problem once. We are coming to this one with 0 0. Okay, from first node I can go to the two possibilities. Either I can go to the right side, this is the code for the right side. Whenever this is greater than, I can go, so you will reach there. Okay, now from there, so 1, so from 1 you will go to 3. Okay, from 3 I cannot go in this direction, but I can go in this direction. I plus 1. Okay, so well, can it cause problem? Not sure, let me just edit once. Okay, so you reach to 3. From 3 I can just go to the downside, which is 4. So you will compare, hey, it is valid, okay, you will, that is 4 is greater than 3, you will come here, you will pass the last node. Okay, now once you are at the last node of the matrix, okay, one thing I missed here. So that is the thing you need to think about, you need to observe how I am thinking about the problem. Okay, so for here, one case I missed is, once I reach to the last node, okay, means when I is row minus 1, okay, and j is equals to column minus 1, means that is the last node of the matrix. So I just need to return 1 here. Okay, I just need to return here 1 here, because from that particular node these two are not true and we are missing that one count. Similarly, let's say you reach to the last row or the last column, from that you can take one direction, so which is fine. but this is very, very important. Let me note down. Very important to think about it. If you got this particular clue, that means the question is finished. Right. Let us try one more time. Thank God, we got 3, right? So what we will do, I have one more input here. We'll try with that input. So 1 2 3 4. So I'll take 1 2 3 4. Second row is 2 2 3 4. 2 2 3 4. 3 2 3 4. 3 2 3 4. Last row is 4 5 6 7. Sorry guys for okay, what is the row? 4 and 4, and output which we are expecting is 7 here. All right, let us run it. You can see 7. So that means we are able to solve the problem. Now we'll see one important thing here is this is the recursive algorithm we have written. All right, here you will see one problem is for same ij we can come multiple times. Okay, for same ij we can come multiple times. So here there are two problems. There are two problems here. Two problems. One, we are calling the same function for same I and j multiple times. You will say, hey, how? I'll tell you. Let us check this example. So from 1 you are going to the 2. From 1 you are going to the 2. From 2 you are coming to the 4. Okay, yeah. Similarly from 1 you are coming to 3. From 3 you are going to 4. Okay, so let's say after 4 also we would have something. Okay, so from here you will go in that direction, right? From here also you will go. So we are recalculating the path from particular index. So this problem is known as the overlapping subproblem. Okay. This problem is known as the overlapping subproblem. Now about this question I'll tell you one important thing. Okay, let's say you want to come to 4 from 2 and 3. Okay, so the answer to come to 4 from 2 and 3 we can use for when we are coming from 1. So that means we have one important property here is a solution of bigger problem can be calculated from solution of smaller problem. All right, smaller problem. This is known as optimal substructure. All right, very important concept. This is known as optimal substructure. Now I'll talk about these two. So if any problem, just think about it, just understand, try to understand. If any problem is satisfying these two properties, what are those two properties? Overlapping subproblem and the optimal substructure. Okay, then we can use dynamic programming algorithm technique to solve the problem. Now since already we have taken a lot of time in this problem, I'll solve the same problem in the next video with the help of dynamic programming. Okay, one important thing is we'll not do much change. We will keep the same code. We will try to modify it. So stay tuned for the next video. Please like, subscribe my channel.